before solving questions, I would like to introduce a formula to you. The formula is integration of ax plus b to the power n dx. The result would be 1 over a times n plus 1 times ax plus b to the power n plus 1 plus 3 here. Okay, this would be our formula. Okay, here are some conditions. A should not be equal 0 and n should not be equal -1. These are the conditions. Okay, so a cannot be 0 and n cannot be -1. So one more time, the formula is integration of ax plus b to the power n dx. The result would be 1 by a times n plus 1. Here is ax plus b to the power n plus 1 plus c. This would be our result. I hope you guys understand the formula. Don't try to memorize this, we'll get into it. Okay, you will accustom with this formula, no problem. So 15.3, question number 1, 1a. Integration of x plus 2 to the power 9 dx. Okay, so if I compare this formula with ax plus b to the power n, integration of, okay, with this term, what would it be, right? So integration of 1 time x plus 2 to the power 9 dx. Here our a value is 1 and our n value is 9. So the result should be 1 over a is 1, n plus 1, which is 9 plus 1 times ax, which is just 1 into x, that means x plus 2, n plus 1, 9 plus 1 plus c. So the total result would be 1 over n x plus 2 to the power n plus c. This is the result, and the result is absolutely correct here. Okay, I hope you guys understand this math, and this too is not mandatory. Okay, now question number B, integration of 2x minus 5 to the power 6 dx. Guys, you should always need to remember that here b is not that matter anymore. Okay, so here I'm seeing 2 is our a and 6 is our n, so we can apply the formula, right? So the formula would be 1 over a is 2, n is 6, a times n plus 1 times ax plus b. Here b is -5, so keep it like this way, and 6 plus 1 plus c. So 1 over 14 2x minus 5 to the power 7 plus c. This is the result. Yeah, the result is absolutely correct here. Now question number C. The integration of 2 times 3x plus 2 to the power 9 dx. Guys, here this 2 is a constant, so I can pick this 2 like this one. So 3x plus 2 to the power 9 dx here, right? Now this constant 2 is same as 2 times, now here a is 3, our n is 9. So 1 over 3 is a times n plus 1, 9 plus 1 here. Now 3x plus 2 to the power 9 plus 1, n plus 1 plus c. This is our result. So 2 over 30. Here is 3x plus 2 to the power n plus c, right? So I can write it down 1 over 15. So 3x plus 2 to the power 10 plus c. So this is the result. I hope you guys understand this math, right? 1 over 15. Okay. So 3x plus 2 to the power 10 plus 3. Yeah. Question number D. Okay. The similar type of maths, right? So the integration of 3 times 2 minus 3x to the power 4, and here is dx. Okay. Here 3 is a constant. So I can keep it in the front, right? Outside of the integral. So 2 minus 3x to the power 4 dx here, right? So I have to arrange this whole terms. 3 integration. Here is minus 3x, okay, plus 2 here dx. Guys, you have to remember that, okay, here is a 4. Our condition was a cannot be 0 and n cannot be negative 1. Okay, so here a is 3, so which is perfect, and n is 4, which is perfect. So we can use the formula, right? So the thing would be here 3 is a constant, okay, no problem. 1 over a is negative 3. Then 4 is n plus 1 times minus 3x plus 2 to the power 4 plus 1, 5. Okay, see here. So it says that minus 1 by 5 here. Here is 2 minus 3x, that here is meant plus 5 plus 3 here. This should be the result. Okay. So 2 minus 3x to the power 5 plus 3. Yeah, the result is absolutely right. Okay. So don't worry about it. Now question number E. Question number E says that the integration of 7x plus 2 to the power 1 over 3, right? Nice question. Okay, so it should be 1 over n. I mean a is 7, n plus 1. Here 7x plus 2 to the power 1 over 3 plus 1 plus 3. So sorry, this is 1 7 times 3 ones are 3 plus 1 4 by 3 7x plus 2 to the power 4 by 3 plus c. This is 3, guys. Which one was my pen? This one? Uh, uh, this one? Yeah, it is. Okay. So the result should be 3 over 28 times 7x plus 2 to the power 4 by 3 plus c. Yeah, 3 over 28, 7x plus 2 to the power 4 by 3 plus c. Yeah, the result is absolutely correct. Now question number 8. The integration of square root of 3x minus 1 to the power 3 dx. Guys, you must know that square root means 1 over 2, right? So the integration is same as, okay, 3x minus 1 to the power 3, the whole to the power, I guess, yeah, 1 over 2 is the root. So the integration sign is this one. So 3x minus 1, 3 by 2, power for multiplication, right? Now the dx. Now it comes to the normal formation, right? So the fundamentals of algebra, guys, pretty basic algebra. So the formula is 1 over a is 3, n is 3 by 2 plus 1. So 3x minus 1, 3 by 2 plus 1 plus 3. So you can use calculator in this case here. I'm not using calculator. 2, 5. Okay, perfect. Okay, 3x minus 1 to the power 5 by 2 plus 3. Okay, one more line. So 2 over 15, 3x minus 1 to the power 5 by 2 plus 3. Yeah, 2 over 15, 3x minus 1 to the power 5 by 2 plus 3. The result is correct here. So question number F done. Now question number G. Okay. In the numerator there is 6 and in the denominator which is square root under x plus 1. So dx, right? So we can pick 6 in the font. So 1 over root over x plus 1 dx. So we can write it down like this way. X plus 1 to the power negative half. Okay. In the denominator square root means half. So in the numerator which is a negative half. Okay. 6. Okay, 1 over here is a is 1 because the coefficient of x is 1 here, right? So a is 1, n is negative half. Okay, there is no problem. Plus 1, here is x plus 1 to the power negative half plus 1 plus c, right? So 6 over negative half plus 1, which is technically a half here. X plus 1 to the power half, right? Plus c. So we can say that 12 x plus 1 whole root plus c. Guys, the result is 12 times square root of x plus 1 plus c. Yeah, the result is absolutely correct here. Number G. Now, question number 8. The integration of 2 over 5x plus 3 to the power 3 dx here. Okay, there is no problem. What should I do here? Okay, so 2 times 5x plus 3 to the power negative 1, 4 times to the power 3, if I am not wrong. Okay, so here is 2 is fundamental here, and here is this is another thing, right? So 2 to the power cube I can keep away from the I can keep away from the integral, right? But there is a fundamental problem there. Here is a negative 1, but that can be solved because there is a 3 here, right? So 5x plus 3 to the power negative 3. Okay, dx. Now it is solvable. So 2 to the power 3 is 8 here. Now here the formula is 1 over a. A is 5, n is negative 3 plus 1, 5x plus 3 n plus 1 plus 3. I guess the answer is correct. So 8 over 2, right? 2 times 5 which is 10. 5x plus 3 square. I mean, sorry, negative 2. Oh, this is negative 10 plus 3, right? So minus 4 over 5 times 5x plus 3 to the power negative 2 plus 3. Okay, I want to do one more line here. Minus 4 over 5 times 5x plus 3 to the power square plus 3. The result is absolutely correct. Okay, so guys, algebra is very much important. Very much. What should I put? Important. Okay. Now number 8 is done. Now question number I. The integration of 3 over 2 times 3 minus 2x to the power 4. Here is a dx. Okay. So 3 by 2 is a constant. So I can keep it away from the integration. So here is 3 minus 2x to the power minus 4 dx. See, question 8 was much harder than question I. 3 by 2 uh, integration of minus 2x plus 3 minus 4 dx. So 3 by 2 times 1 over a is negative 2. N is negative 4 plus 1 minus 2x plus 3 to the power minus 4 plus 1 plus c here. So 3 by 2 times 1 over this is negative 3, this is negative 2, which is 6. Here is 3 minus 2x to the power negative 3 plus c. I have to do some more lines. Here is 1 over 4 because this is cut down to, so 1 over 4 times 3 minus 2x to the power negative 3 plus c. Okay guys, the last line 1 over 4 times 3 minus 2x to the power 3 plus c. 1 over 4 3 minus 2x to the power 3 plus c. Yeah, the result is correct. So our question 1 is done. So pretty much this is the thing actually. Now I can start solving question number 2. There are 6 questions actually here. So question number 2. So the question is, a curve is such that its differentiation result has been given here. Given that the curve passes through the point 0, minus 1.95. Find the equation of the curve. Oh my god, I have to use the calculator here. I guess I don't have right now. Okay, so the differentiation result is given like a 4x plus 1 to the power 4. Okay, now integrating both sides here. So 4x plus 1 to the power 4 dx here. So here it would be y, and here it would be 1 over a is 4 here, and n is 4 plus 1. Now 4x plus 1 to the power 4 plus 1, which is 5 plus 3 here, right? So 1 over 20. Profession by 4x plus 1 to the power 5 plus c. Okay, now we have to figure out the value of c. So we can input the graph passes through the point 0, 1.95, right? So our x value would be 0 and y would be minus 1.95. Okay, minus 1.95 and x value is 0. If I input 0 here, it would become a 0. 4x would be 0, right? So 1 over 20 times 0 plus 1 to the power 5 plus c. So it would become 1 over 20 plus c here 1.95, right? Okay, okay, minus 1.95 and here is minus 0.05. This is equal to c. So our c value is negative 2. So our y would become 1 by 20 4x plus 1 to the power 5 negative 2. This is the answer. And the answer matches clear. Okay, there is no problem. Done. Guys, I have to check the sound of my microphone. Okay, guys, now the question number 3. A curve is such that its differentiation result has been given here. Given that the curve passes through point 4, 11, find the equation of the curve. Okay, pretty simple one. So the given differentiation has been given as x plus 1. So I can write it down like this way. So 2x plus 1 to the power 1 by 2. Okay, now I'm taking integration sign, I mean on the both sides. So from the first left hand side we will get y, and here our 1 over a is 2, n is half plus 1 times 2x plus 1 to the power n plus 1 plus c, which is the integration result. So y is equal to 1 by 2, which is 3 by 2, 2x plus 1 to the power 3 by 2 plus 3. So this is here 1 by 3, because this 2 and this 2 would be eliminated. So 1 by 3. Here is 2x plus 1 to the power 3 by 2 plus 3 here. This is y. Now we have to find out the value of c. For figuring out the value of c, we will input this value. So our y is 11, x is 4. 1 by 3, 2 times 4 plus 1, 3 by 2 plus c. So here 1 by 3 times, okay, 2 4s are 8 plus 1 9 to the power 3 by 2. Okay, plus c, here is 11. Now here 9 to the power 1 by 2 is a square root, so 3 to the power 3 here. Okay, plus c. So 3 to the power 3, this is 27, right? And here is 3, so 9 plus 2, this is 11. So our c value is 2 here. That is how I calculated here, right? 9 to the power 3 by 2. Note. Okay. So it can be written as 9 to the power 1 by 2 to the power 3. Okay. So root over 9 to the power 3. So root over 9 result is 3, to the power 3 is 3. So 27. Okay. From this part and from this part. And here is a 3 as a divisor. So it would become 9. So C value is 2. Algebra is pretty much important here. So our y result would be, okay, 1 by 3, 2x plus 1, 3 by 2 plus 2 here. So I can modify this result like this way. 2x plus 1 to the power 1 by 2, the whole thing to the power 3 here, plus 2. So 1 by 3 times 2x plus 1 to the power square root, and this total whole value to the power 3 here, plus 2. Yeah, I can write it like this way, there is no problem. At the same time, I can write it like this way as well. So 2x plus 1 to the power 3, and the top value is square root. So I can shift this one and I can shift this one, because x to the power n to the power n is exactly equal x to the power n to the power n. There is no problem. Plus 2. This is the answer. Question 3 done. Question 4. A curve is such that its differentiation result is 1 over root over 10 minus x. The curve passes through the point 6, 1. Find the equation of the curve. Okay, the same graph. The differentiation has been given as 1 over root over 10 minus x. So it can be written as minus x plus 10 to the power minus half. Okay, so I'm taking integration on both sides. Minus x plus 10 to the power minus half dx here. So here is y. Here is 1 over a is negative 1. A is negative half plus 1 times minus x plus 10 to the power negative half plus 1 plus c. So 1 over negative 1 times minus half plus 1. This is positive half here. Here is 10 minus x to the power just a half here, right? There is no problem. Negative half plus 1 is positive half, right? Plus c. Here 2 would be front and here is negative 1, so I can put negative 2 here. So 10 minus x, I can take a square root here because of this half plus c. So y is equal to this thing. Now I have to find out the value of c. The curve passes through 6 comma 1 point. Okay, so y value is 1, x value is 6, minus 2 square root of 10 minus 6 plus 2. So 1 negative 2 here 4 which is 2. Okay, so 4 1 5. So 5 is equal to c. So y is equal to minus 2 square root of 10 minus x plus 5, which is the result. So I can write it down like this way: 5 minus 2 square root 10 minus x. This is also the result. Exactly the same thing. Question number 4 done. Now question number 5. A curve is such that its differentiation result has been given here, where k is a constant. The gradient of the normal to the curve at point 2 comma 2 is minus 1 by 8. Find the equation of the curve. Guys, before going to that math, we have to get uh, to know that this is called the tangent. This is called the tangent, right? So we have to get the gradient of the tangent. So minus 1 by 8 times x is equal to negative 1. So our x would be 8. So which is the gradient of the tangent? Okay, gradient of the tangent. You have to remember this thing. So 8 would be the gradient of the tangent. We don't need gradient of the normal. We just need gradient of the tangent. So the first thing first, the given differentiation result is k times 2x minus 3 to the power 3 here. Okay, so I'm taking integration on the both sides. So dx, here k is a constant, so 2x minus 3 to the power 3 dx here, right? So here is y, here is k, then is, so 1 over a is 2, n is 3 plus 1, so 2x minus 3 to the power 3 plus 1 plus 3 here. So y is equal to k over 3 plus 1 4, 4 2 is 8, 2x minus 3 to the power 4 plus c. This is the thing actually. So here are two variables. K is also a variable and c is a variable here. Okay. Now, at guys, always remember that tangent and normal passing through the same point. 2 comma 2. At 2 comma 2 here. So y value is 2, k by 8, x value is 2 to the 4 minus 3, which is 1, 1 to the power 4 plus c. So which is 2 k by 8 plus c. That means here 16 is equal to k plus 8c. This is the equation. Okay, this is the equation. Now this value is 8, the gradient of the tangent. So I can input 8 here, k. Now 2x minus 3 to the power 3. Okay, at 2 comma 2. 8 is equal to k times 4 minus 3 to the power 3. So 8 k 1 to the power 3. So our k result is 1. This is to the power 3. Okay. So if k is equal 8 here, so I can write it down. 16 is equal 8 plus 8c. It says that 8 is equal 8c. So c is equal to 1. So now I just need to input the value of k is equal to 8 and c is equal to 1 in this equation. So y is equal to k value is 8, 8 over 8, 2x minus 3 to the power 4 and the plus 6 is 1. So it says that y is equal to 2x minus 3 to the power 4 plus 1. So this is the result. Need to check the result. Number 5. 2x minus 3 to the power 4 plus 1. Absolutely correct. My goodness. Yeah, it's done. So the differentiation result of a curve has been given as 2 times kx minus 1 to the power 5 here. Okay, we have to find out the equation of the curve. So I'm taking integration on both sides. 2 is a constant, so I'm keeping it in the front. Okay, so here is y. Here is 2, 1 over a is k, n plus 1, which is 5 plus 1. Here is kx minus 1 to the power 5 plus 1 plus c. So 2 over 6k, kx minus 1 to the power 6 plus c, which is y. Here, like I can write it down like this way: 1 over 3k, kx minus 1 to the power 6 plus c. Here, guys, k and c are unknown, so we have to find out these two values using the two passing points. First thing first, at 0 comma 1, when y is equal to 1, x is 0, so 1 by 3k, so k times 0 minus 1 to the power 6 plus c. So here 1 is equal to 1 by 3k and negative 1 to the power 6 is a positive 1, so here is only plus c. So I can keep like 1 minus 1 by 3k is equal to c. Okay, so I'm making c as a subject from this equation. Okay, at another point is 1 comma 8, 1 comma 8, so y is 8, 1 by 3k. Okay, 1 by 3k, x value is 1, right? So k minus 1 to the power 6 plus c here. So 8 same as 1 by 3k, same as k minus 1. I'm keeping it like this way, plus c. The value of c is there 1 minus 1 by 3k. Now I can subtract this one from left hand side, so 8 minus 1, which is 7. So k minus 1 to the power 6 down 3k minus 1 by 3k. There is 7, so 3k is our LCM, like k minus 1 to the power 6 minus 1 here. Okay, this is the fact actually. Now guys, there are no alternate methods to solve this question, so we have to use like a trial and error of values of k. So if k is equal to 1, if I input here 1, this term would be 0 here and it would become negative 1, and in the down that would become 3, then 7 not equal to minus 1 by 3. Okay, so we have to use some other values of k. So my second case is, if k is equal to 1, then k is equal to 2, then 2 minus 1, which is 1, 1 to the power 6 is Like 1 minus 1 is 0, so 7 not equal to 0. Now if I pick k is equal to 3, then 3 minus 1 to the power 6 minus 1, 3 times 3, so 2 to the power 6, right? 2, 4, 8, 16, 32, 64. Okay, 64 minus 1 divided by 9, so 7. So we can say that the value of k is 3 here. Okay, guys, there are no alternate methods. If I want to use binomial for k minus 1 to the power 6, it would become massive. Okay, I don't know who put the question here. He or she is just stupid. Okay, if our k is equal to 3, then our c value is 1 minus 1 by 3k. So this is 1, 3 times 3 here. So 1 by 9. So 8 by 9 is our c. So the main equation was y is equal to 1 by 3k kx minus 1 to the power 6 plus c. So our k value is 3 and c value is 8 over 9. So 1 by 3 times 3, here k value is 3x, I mean 3 minus 1 to the power 6 plus c is 8 by 9. So here 1 by 9, 3x minus 1 to the power 6 plus 8 by 9. So here is 9, 3x minus 1 to the power 6 plus 8. Yeah, the result is correct here. Now my tips is that, guys, if you want to solve like k minus 1 to the power 6, please do not do it by binomial. Tips is to use like trial and error method. I hope you guys understand the math. Thank you so very much for joining with me. If you need one-to-one session in Dhaka city, so you can definitely knock me in this number, and I'm available for online batch as well. So thanks.